Here we need to solve the equation algebraically and obtain exact answers. In this particular problem, we have a radical, and we have the variable that's in the radicand. We need to get that variable out so we can solve this. We have a square root, so we're going to get rid of this by squaring both sides. So we'll write x plus 1 quantity squared equals the square root of x plus 7 squared. Squaring out x plus 1, we get x squared plus 2x plus 1. And the square root and the square root will cancel each other, and we'll be left with x plus 7 on this side. We want to get everything on one side, get the other side equal to 0, so we're going to subtract x and subtract 7 from both sides. When I do that, we get x squared, 2x minus x gives me plus x, and 1 minus 7 gets me minus 6. That equals 0. Again, I've got a quadratic equation, and I'm going to try to solve this by factoring. This will factor into x plus 3 times x minus 2. We set that equal to 0. Use the zero factor property, set each factor equal to 0. X plus 3 equals 0, or x minus 2 equals 0. So we get x equals negative 3, or x equals 2. And we need to be careful with this kind of an equation, because when we square both sides, we could introduce extraneous solutions. So with equations involving radicals with even indexes, we really need to check our answers to make sure they still satisfy the original equation. So we're going to substitute x equals negative 3 into our original equation and make sure that it's okay. So we have negative 3 plus 1. That'll get us, let's write x is negative 3. Negative 3 plus 1 will get negative 2. Negative 3 plus 7 is 4, and the square root of 4 is 2. So we see that negative 2 does not equal 2, so x equal to negative 3 is not one of our solutions. We'll let x equal 2. Plug that in. 2 plus 1 is 3. 2 plus 7 is 9, and the square root of 9 is 3, and that checks out. So this equation has only one solution, which is x equals 2.